Measure reaction time experiment. So the materials of this project, we first need to use a reaction time sheet, a paper to record data. We also need to use Microsoft Excel to calculate data. The equations we used for this experiment are h equals 1 over 2 gt square root, t equals square root 2h over j equals square root h over 5. All acceleration of gravity are used easy number as 10 meters per second per second. So process of project. First of all, we need to prepare the reaction time sheet. Then I choose the appropriate subjects for this experiment. Later, I found 10 people, 5 male and 5 female, to do the experiment at repeat 10 times. The experiment, which is someone holds a reaction sheet vertically to draw the sheet without any attention and the other person catches it. I wear this experiment to see people's reaction time to measure the time between the sheet falling until he or she catches. Graphs of time and distance. The first graph I draw is the distance falling versus the reaction time, equal time increments. The second graph is the distance falling versus this reaction time, equal distance increments. So here are data that I calculate. The first data is equal distance. The second data is equal time. Later, I also did the experiment reaction time without any stimuli. So I chose 5 female and 5 male to do these experiments. I did this experiment 10 times per person. Later, I used the data to calculate the mean and the standard deviation and put this in Excel. I use the same way to do the reaction time without extraordinary stimuli. Again, I did each person 10 times and calculate mean and standard deviation. Question 1. What was the difference for each subject in average reaction time with any without the extraordinary stimuli? So, from the mean number we can see, reaction time with stimuli is longer than the reaction time without stimuli. Question 2. In your opinion, did the extraordinary stimuli you used affect subject reaction times? In my opinion, the extraordinary stimuli have the effects of the subject reaction times. We can tell this clearly by the mean numbers. Compared to each other, the reaction time without stimuli is shorter than the reaction time with stimuli. Question 3. Can you come to a conclusion about reaction time of male versus female when there are minimal extraordinary stimuli? In the condition of minimal extraordinary stimuli, I consider male reacts faster than female. In my opinion, in my experiment, if they are similar age, men are more sensitive than women. Question 4. Can you come to a conclusion about the changes in reaction times of male versus female when the extraordinary stimuli is used? I consider male reacts faster than female. In my experiment, if they are similar age, men are more sensitive than women. Question 5. Do your results have any bearing on the effects of taking a cell phone while driving? According to my results, the extraordinary stimuli will make the reaction time become longer. It means people will become slower when the stimuli happens. Take on cell phone is an extraordinary stimuli for the driver, so it will affect the driver while driving. Question 6. Imagine that you were measuring the reaction time of someone with an extraordinary slow reaction time. A. Would the current car store be suitable? Why or why not? B. How might you measure the person's reaction time? To answer for the first question, no, because S equals 1 over half gt squared. If t bigger than 2, then S will be longer than 20 meters, so that it is not suitable for the people who have slow reaction time. The answer for the second question. I think this person needs a test of the reaction time in multiple ways. There is an APP, which means do not touch the white. It's better to test people's reaction time. Question 2. Differences of reaction times between the Earth and the Moon regarding the construction of a RT strip. The reaction time on the Earth is different than the reaction time on the Moon because the gravity on the Earth is greater than the gravity on the Moon. According to the formula T equals square root 2h over g equals square root h over 5, when g is smaller, the reaction time gets bigger. Therefore, the reaction time shades should be use greater units for measuring. It is like changing distance units centimeter to meter because the shade will drop slower. Question 3. If a person have very long reaction times, would it be easier or harder to measure a person's reaction time on the Moon with Moon RT strip than for the same person on the Earth use Earth RT strip? It would be harder to measure his reaction time if the person had very long reaction times, because according to the formula T equals square root 2h over g, when g is smaller, the reaction time gets bigger. On Earth, the person has long reaction time. When on the Moon, the reaction time becomes longer. It's hard to measure. Question 4. If a person had very short reaction times, would it be easier or harder to measure a person's reaction time on the Moon with Moon RT strip than on the same person for the same person on the Earth using Earth's RT strip? It would be easier to measure his reaction time if the person had very short reaction times, because according to the formula T equals square root 2h over g equals square root h over 5, when g is smaller, the reaction time gets bigger. On Earth, a person has shorter reaction time. When on the Moon, the reaction time becomes easier to measure. But this is the end of my presentation. Thank you.